So, like I said, if you're given a question like this, how many ways to group 4 people in twos? I think I can write it better so that all of this will fit into a line. How many ways can we group 4 people in twos? How many ways can 4 people or 4 students, if you like, be grouped in twos? So the group is what we can call R. The number is what we can call N. Okay? Let me zoom it in a bit. Maybe the 200. Are you still there?
Yes, sir.
How many ways can 4 people? So 4 is the total number, which we call N. Be grouped in twos. So the general formula is, because this is about permutation and combination. So this question is related to permutation and combination. Let me write it in blue. And combination. All right, so how many ways can we group 4 people in twos? You see that, and I said you can use letters A, B, C, D to represent the 4 people. If you try grouping them, you can have A and B, A and C, start with A with B, A with C, A with D, again with B, B with C, B with D, and so on. Because if you start with B, if you do B and A again, you already have it, A and B. So A, B, A, C, A, D, B, C, B, D, and C, D are the only possible ways. A with B, A with C, A with D, B with C, B with D, C with D, and so on. And if you check, because there are fewer numbers involved, we can afford to do all this, and we discover that there are only 6 ways. But I said there's a way you can do it if the number is so much that you can't have the luxury of time to write out all this. Are you getting it?
Yes, sir.
6 ways, okay. So the general formula is N combination R. And N combination R is N factorial over, open a bracket, N minus R factorial times R factorial. Factorial simply means multiply that number in decreasing way until you get to 1. An example is this. So this is, when I say N factorial, it's simply, the word itself means N factorial. And it simply means N times N minus 1 times N minus 2 times N minus 3, and so on. Did you get that?
Yes, sir.
So, for instance, 4 factorial would mean what?
4 factorial. 4, 3, 2, 1.
So 4 factorial means 4 times 3 times 2 times 1. Okay. So N combination R, which is N factorial all over N minus N, open the bracket, N minus R factorial times R factorial. So for 4 combination R, which we are working on based on this question, there are 4 people involved. We are going to group them in twos. So that's actually 4 combination R2. for combination 2. Alright, so that's it. Now let's look at the question. 4 combination 2, of course, is 4 factorial divided by 4 minus 2, like saying n minus 2 factorial or n minus r factorial, then times r factorial, that's times 2 factorial. Okay, and the simple way to do that is, are you listening to me?
Yes, sir.
Since you know that there's another 2 factorial that you have down here, so instead of writing 2 times 1 times whatever, you just stop at 2, because it will.
So in the like what it is, 4 times 2 factorial.
Pardon?
That's like that 2 factorial. It should, you know, it's the denominator. You wrote 4 times 3 times 2 factorial. In the numerator, sorry, numerator.
Yeah.
What? So that 2 factorial is 2 minus 1 is 4
2 times 1. Let me tell you why I wrote it. Let's look at this example here. Let me tell you why I wrote it like that. Read out this question we want to work on.
A group of 7 people inside. Each person should count all of the other people.
You're not very audible.
How many countries are there?
Are you far from this thing? It's okay.
How about now? Can you hear me?
It's better now. Okay. A group of 7 people are in a class or enter a room. Enter a room, it doesn't really matter. Each person shakes hands with all the other people in the room. How many handshakes are there in total? It's just like saying, how many ways can you arrange 7 people in twos? So that would be 7 combination 2. 7. When one person shakes hands with another person, is it not 1 and 1, which is 2? But it says each person shakes hands with all the other people in the room, one after the other. Now you are not going to be. How do you shake hands with 2 people at the same time? When you
like, if you're an usher, you can be like, oh, walk in church.
One person at a time now. You will see shake hands with one person at a time. You and the other person make up 2. You and the other person make up 2. So it's like saying, how many ways can you group 7 people in twos? So it's 7 combination 2. Okay, so 7 combination 2 will be what? 7 factorial, right?
7 factorial.
Okay. That's 7 factorial over 7 minus 2 factorial times 2 factorial. Times 2 factorial, which is equal to. Now, you will now understand why I didn't bother to write all of that to the end. What is 7 minus 2 What is 7 minus 2?
5.
So 7 minus 2 is 7, is 5 factorial. So instead of writing 7 times 6 times 5 times, I can just simply write
7 times 6 times 5.
7 times 6 times 5 factorial, because there's also 5 factorials down. Divided by 5 factorial times 2 factorial. So 5 factorial will cancel out 5 factorial up. So we have 7 times 6 all over, and 2 factorial is 2 times 1.
2 times 1 is that's 2. 7 times 3, that's 1.
Okay, let's finish it up here. So this gives us, what's 7 times 6?
Can I do 7 times 6 over 2 times
Yeah, 7 times 6 over 2. 7 times 6 is 48.
42.
48 over 2.
42 over
42. 6 times 6 is 42.
2.
Yeah, it's 42. 6 times 6 is 36. So 7 times 6 is 42. 42 over 2 gives 21, right? 21?
21.
So there are 21 ways to do that. You know, when the number gets so big, you better use a formula that can get the answer easily. So the answer is 21. Alright, so I think I should take this further because we can get a question slightly different from this.
I will tell you my math. You know when you said that you would do a portion of when it's syllabus. So I think in the math panel.
Pardon?
You know when you said that you want a question of when it's syllabus.
Yes.
I tried in the business math group and I was like, what is this? I expected for that math to not math.
Is this further maths or math?
It's for that math.
Oh yeah, you expected to do this in further maths, obviously.
Yes, sir.
This one should be a normal question in further maths. Okay, if we're not interested in the arrangement, like if it's about grouping two people but we're not interested in the arrangement, or we're interested in the arrangement, like A, B is different from B, A.
Okay. AB is different from
Yeah, if AB is different from BA, you know, that means we are still going to have AB, BA, AC, CA, AD, DA, BC, CB.
how is it? 16.
This particular one would have given us how many?
16.
This particular, are you sure it's 16? This is 6. We got 6 ways now. How will it be 16?
So that if we do it that way, we said you don't care about arrangement. Like if you care about arrangement,
If the arrangement is also important, in other words, an arrangement of AB is different from an arrangement of BA, then of course, initially it was 6. So what will it be? Are you sure we're not going to be having double of this? BA, CA, DA, CB.
we didn't do for D at all.
We don't have. I thought it would just be 2 times of this now. I thought it would be just 2 times of this.
But we didn't do DC, we didn't do DA, we didn't do
That's what I just did. That's what I just did by changing it. Instead of AB, I mean for AB I now have BA. For AC I now have CA. For AD I now have
we
DA.
do A as well.
We didn't do what?
I didn't do A,
A what?
AA.
AA.
Yes, somebody should yeah.
No way, of course.
Because of the question.
No way, of course. We are trying to group 4 people in 2, so there must be 2 different people.
Okay. But if you could do AA and
Let me add another frame to explain what I mean now. Oh, we still have a space down. I didn't even know that we still have a space down. So we can explain what I'm thinking about here. So this is what I'm talking about. If we need to rearrange this when the grouping is also, the arrangement is important. So look at this. This is the question. This one is grouping. Combination is about grouping. Permutation is about arrangement. So let me ask this question again. This very question I asked up here. Read out the question again. This example.
how many views can N?
No. How many? Yes, can 4 people be grouped in 2s? Okay, let me ask it again. That's example number 1. Oh, sorry, moved a bit. Example number 1. So this one will be example number 2. It's going to be about grouping. Example 2. Example 2 will be how many ways can we arrange. So you see, this is about arrangement. How many ways? Can 4 people, or let me just say four letters, be arranged in twos? Okay. That one is permutation. The formula is this: n permutation R is simply n factorial all over n minus R factorial. There's no more, you don't have any 2 factorial.
No, sir, I've seen this NCR.
Where?
Maybe
From?
I've seen this on my calculator, NCR.
Yes, no, it's on. It should be in the calculator, especially. Yes, it should be in that calculator you're using. You even see the one for factorial. So if you press on your calculator n for combination 2, it will just give you the answer directly.
But I don't think this question will come in if I'm qualified.
You try and work it out so that you not lose marks for steps. By the way, all your hard maths questions papers are calculator based now.
No, paper 1 is not
Paper 1 is not calculator based, okay. So n permutation R is n combination n factorial over n minus R. This would have been 4 factorial all over 4 minus 2 factorial. And you see we'll get 12. Because there will be 12 ways to arrange this. What's 4 factorial?
4 times 3 times 2 times 1.
Okay. 4 times 3 times 2 times 1 all over 4 times 2. 4 minus 2 factorial is 2. 2 factorial, that is 2 times 1. You know? And of course, this one will just give 12. That's what I was trying to tell you. You said 6 ways, and I was drawing your attention to the fact that it will just be double of each of all these ones. So it will be 12 ways.
Yes, sir. Because I want you to the situation where it can be.
It can be what?
Yeah. A,
A, like AAA, BBB.
Yes.
Like 3 ways. Of course, whichever way. I can just give you a question here. Sorry, let me write this answer. 6 ways. So, in the light of what you asked, you can just answer this question. So this is an exercise. Maybe I should use 7 different colors, or maybe 10 different colors. So, can you solve this one? How many ways can you arrange 10 different colors in trees?
In 3, 10 is N, 3 R. They do arrange permutation. They do
No.
10 I over 10 minus 3.
Just a moment, let me write it down as you said it. Arrangement is about permutation. While grouping is about combination. Okay.
Now,
Go ahead. I hope you have your pen tablet.
that's why it came like my
You don't have your pen tablet?
I have a pen tablet, but it's like my
Please
You always erase it when I write.
answer it here.
You always erase what I write and you write it for me.
What did you say?
Whenever I write, you always erase my writing. I write.
Oh, okay, please zoom in very well. Zoom in very well. Zoom in very well and make sure you write it properly now. So that when you're reading it again, you understand what you're writing.
I carry my handwriting. That's what I have to
Okay,
I read this one existed.
beautiful. Are you ready? When you're ready, let me know. I'm waiting for you. So you are busy still connecting your pen tablet. Now I've caught you.
That's the thing.
Wasting precious time. Alright, let's go.
This is the presentation.
Okay, go ahead. Please zoom in properly so that you can write more legibly. Okay.
So 10 is N, 3 R. So N. Oh, don't worry. You know what? I'll just do this max. So what am I going to do? This cancel this. Answer equals to 9 times 8 is 7 to 2. Okay, sir. I'm done.
So if you were to, that's correct, 720 is correct. If you were to do this by having to write down these, I can imagine how long it will take you, maybe a whole day, to figure this out. If you, and God help you, you don't make a mistake in the final answer. So
Can I do combination?
You mean you want to solve another question on combination? I think we even have a space here.
Can I solve this question using combination?
It's about arrangement, so it can only be permutation.
So can you make the question about
Mm.
Or
Okay.
make this one A, arrange, B, combine.
This is 10 permutation 7. Okay. There's a way the question can be structured, and you will need to pin some of the.
I feel like they can also use the question to confuse somebody.
Mm-hmm. How about if, for instance, you're asked to. Okay, let me look at this. Let me use an example to illustrate this before we talk about it. I'll use. Go to the next page. I have letters A, B, C, T, and E. And I want to arrange them in such a way that I'm thinking of another way to do this. In threes, such that A and E are always the first and the last. Can we try that first of all? We want to arrange them in threes.
Okay.
But A and E should always be first and last.
Oh, that means.
First of all, the question is, we are arranging this A, B, C, D in threes. But A and E should always be the first and the last, respectively.
But A and E is always constant.
Yeah, exactly. A and E are pinned. So when some things are pinned, you need to take that into consideration. But let's arrange first of all. What are the possible options? We can have. Okay, you want to write? Hold on, go ahead. Let me allow you to write. A, B, E.
What are the options?
Are you sure?
Set A and E, A should be the first and E should be the last.
Yes. Okay.
Wait, so can you do this as well?
No, now. How can you add it two A's? You can't do A because there are not two A's, it's just one A. So A, B, E, A, C, E. Let me even write it on the question. Such that A and E, sorry, I need to erase this so I can. Such that arrange the 5 letters in threes, such that A and E are always the first and the last, respectively. Can I make it 7 so that we can get more? Let me make it 6. So A and F. Are you ready?
I'm ready.
I'm going to change the question slightly. I want us to get something that we can work with. So the letters are A, B, C, D, E, and F. So can you do that again? Mm-hmm. Go ahead.
So first you have have A. Okay, F increase. A, B, F. A, F. A, F. A, B, F. Shall I wait there? Can you start with F? Can I start with F?
Can you do one?
Can I start with F?
And when we said A and F must always be the first and the last, respectively. So you can't start
So
with
the
F.
A dash. I can't start with F. A has to be the first and F has to be the last.
Okay. How many do you get?
1, 2, 3, 4, 4.
Okay. So the question is this: how many ways can you group? The third and the fourth letter. Okay. It says, how many ways can you group 7 letters in twos such that the third and the fourth letter are always together? Did you see what I wrote?
Yes, sir.
Like A, B, C, D, E, F. 1, 2, 3, 4, 5, 6. F, G. 1, 2, 3, 4, 5, 6, 7. The third and the fourth letter are always together.
So that's the 7 letters.
Yes, so how many ways can you group 7 letters in two such that the third and the fourth letter are, or letters are always together?
So about this arrangement.
Group. Remember, it's a grouping thing. How many ways can you group 7 letters in twos such that the third in threes, I made a mistake in the question, in threes, such that the third and the fourth letters are always together? Can you even try it? Let's even try writing it out. The third and the fourth letter are always together.
Let me try. Can you write DC?
No,
The same thing.
CD in order, together in order. The fourth in the right order. Okay,
So ACD and ADC are not are the same.
the right order. Yes,
My question: ADC and AC.
yes. C and D must follow sequentially. CD, not DC.
Now, can you ask me a question where it doesn't have to be right?
That's arrangement. When it is arranged, when you're asked to arrange, so they will be in different. The arrangement will be considered. The
What's
code.
fine, this one, if I cannot write FC.
So what I'm saying is CDE and ECD. are the same because it's about grouping. Or you want me to change the question to arrangement? How many ways can you?
No. So this one. So this one. This one. No, for this one here. I'm going to write FBA. Said I can't write.
You want to write one?
For this one. For this question, I'm going to write FBA.
The previous question.
Yes, first question.
I think the previous question is arrangement. You know you can't write it because we've already been told that A and F, these are conditional permutations. A and F must be the first and the last.
So in non-conditional permutation, A, B, F, and F, B, A are two different things.
Say that again.
In non-conditional permutation, are you saying that A, B, F, and F, B, A are two different things?
For arrangement, yes. There are no conditions, but they've told us that A and F must.
So one can include it inside.
Yes, now if there's no condition preventing us from that arrangement. But here, it's already stated that A and F must appear in the first and last, respectively. So you can't start with F or any other thing apart from A. So there are only 4 ways. There are only 4 ways to do this. But I'll look at this. With what you have, are you done?
Yes, I'm listening.
So how many ways did we find out?
6.
The question again, how many ways can you group 7 letters in threes such that the third and the fourth letters are always together in the right order? Okay.
6.
Are there 6 ways? Okay. You
Yeah,
can afford to write this because there are fewer. How about if the numbers are so many, like they say, how many ways can you group 20 or 100 letters in threes so that the 50th and the 51st letters are always together? You can't be writing out this. So there has to be a way to do this. Right? Now, since this is also conditional, so by the way, I want to let you know that all these ones are conditional permutation and combinations. This is the example number 3 is conditional permutation. Example number 4 is conditional combination.
Okay.
Now, the way to do this is, they said the third and the fourth must be together, right?
Yes, sir.
So it's like pinning them together, third and fourth, pinning them together as one letter. You will understand what I mean.
They're having like 6 letters.
So they are now how many letters?
6.
They are actually 6. We are considering 1, 2, 3, 4, 5, 6. That's what I was trying to explain to you there, but I noticed that I didn't use the right example. So this is the right example for it. So there are actually 6 things you are considering. So you applied the formula for combination, but bearing in mind that it's 6, they are now 6. So what's the formula? What will you do if you were to use the proper formula for combination? Yes.
I'll use.
Remember, let me write it down that.
I.
Hold on, let me say that. Note that C and D have been pinned as one. As one. All right, so do that very quickly.
6I.
That's combination, no?
Maybe it's combination.
6 combination 3, right?
Formula is. Sorry.
It's combination.
Yeah, I know.
Let's quickly solve it.
Formula is.
N combination R. Please. Okay. Okay. So go ahead and solve this.
times 3i over 6 minus 3 is 3. That's 3i times 3.
Times 3 factorial again.
So this can cancel this.
Use a different color. Please use a different color. You're mutilating the work. That's why I would want to erase the work. I need it to be neater. Don't worry, let me just write it.
See what I said?
I'm sorry. I just want it to be neater. So this is equal to, you said it's 6 times 5 times 4 times 3 factorial all over 6 minus 3. 6 minus 3 is
Yes, sir.
3 factorial.
Yes, sir.
3 factorial times 3 factorial. Okay, so just use a different color to cross out that.
Okay. So I should get 6.5 over 30%. So that's gonna be 6 or 120. That's 20.
6 times 5 is 30.
Yeah, 30 times 4 is 120.
How come we're not getting? That means you didn't write all of this. So you've not written out all. You've not written out all.
Okay, what should I write?
You still have more. You
Can I
have.
write?
You have not written out all. You still have more to write. I think you need to write out the rest so that you can complete it. But that's how it should be done.
Because I
Okay.
want to do the rest.
You have to write all of them out now. Just a moment.